Hi, good morning to everyone. Like we said, global hotspots and coastal cephalopod diversity. See, this was an idea that arose during this meeting, where we danced, Inger took nice pictures with squids, hats, and there was a workshop, biogeography and phylogeny, and I gave a talk there, and I spoke about macroecology. So, what is macroecology? It deals with the study of relationships between organisms and their environment, but at larger scales. And there is always a need to characterize it with statistical patterns, the abundance, distribution, and diversity. So, I tried to use this under the cephalopod world, and during that workshop, I spoke of a previous work that I published, where I tried to understand the contemporary patterns of coastal diversity in the Atlantic. So I split the Atlantic in two, in western and eastern, and I tried to characterize the large-scale gradients of species richness. So the patterns were more like this. So again, western and eastern, and you can definitely see one thing, that the zenith of diversity is not on the tropics, it's on mid-latitude, and this was interesting. And also, of course, there was also very interesting data regarding the octopus diversity, which was around the Caribbean, the highest diversity. So, but the main point was the zenith was not on the tropics, and I'm going to speak about it a little bit later. Then we expanded this approach to the open ocean, and we published this, of course, in the Atlantic again, because it was easier. So we split the Atlantic in several regions. It was based on Bacchus, so it was a mesopelagic zoogeographic division based on myctophytes. And I used this approach, and I split it like that, and we count the number of species that you knew in each of the areas, and again, the richest areas of diversity was not on the tropics. So it has a strange numeration, the panel on the top, but so the 3s and the 5s are the tropical areas, and you can see that they are not the most diverse. Of course, I also plotted with the depth gradient, and we observed, of course, a decreasing trend with depth. So this, so let me talk about this slide first. So during this meeting, I gave a talk, and I told my colleagues that I wanted to go globally, and well, it was a daunting task, but I was very persuasive, and they helped me. And this is what I'm going to show you today, is we expand this globally, and this is just a first look of the database. I'm not going to bring any statistical part of it, so just the common trends and the basic trends, okay? So, but before that, this was just published in Trends in Ecology and Evolution, which is I like the title because it really came to my mind the same idea that I had previously. There is no unimodal trends of diversity. Mostly they are bimodal. So these guys just said, so the latitudinal gradients in species regions are generally assumed to be unimodal with a tropical peak. We show that it is bimodal with a dip near the equator for marine species. So this was what I got in the Atlantic. So I really like to enjoy reading this paper. So and now let's see how it goes globally. So the thing was, during this workshop, how are we going to plot this? According to climate regions, to the well-known longer probabilities, we decided to use the new system that Spalding described in 1997. So it's marine ecoregions of the world, and they are I'm going to ask my student Vasco, it's here with me and he knows definitely. How many regions, Vasco?
232.
So there are 200 something ecoregions. So yes, Vasco really helped me with this. My master student is there, so this was the award coming here to show you this also. So we compiled a database with 371 species. We excluded the rare species, of course. And well, we used all the catalogs available, and it was very hard to combine everything, but we did it. So let's start with the Cephalopods. So we saw that the hotspots of the cuttlefish are near the central current with 21 species, the East China Sea with 21 also, and the East African coral coast. Let's see. So here and here. So this is the East African coral. Cold spots. Of course, there is many places where we don't have cuttlefish, right? So we are considering the cold spot. We are going to call cold spots the areas with low diversity. Okay. So, and of course, we saw that in South Pacific Islands, usually we only have 1 or 2 species. So let's talk about Cephalopods. Xavier. Yes, of course, the Mediterranean are the most diverse with more endemics. And up to 15 species. Is it correct? So yeah, so the hotspot in the Mediterranean, and they are very widespread, but mostly in the other parts of the world, just 1 or 2 species. This is very interesting to understand historically, because the Mediterranean was closed and this originated radiation. So there is an historical explanation for these endemics in the Mediterranean. Then we have the Cephalopod. The hotspots are in central Ecoregions current and in Australia, and in other places just 1 species. So, and we have to confirm this because we found on the databases on these Chile islands 1 species. So definitely I want to look at again these ones. The José, the 2 hotspots are the North Australia and Indonesia and the South Africa. And then we have 1 species on the eastern and the Indian and Indo-Pacific oceans. In terms of Latitudinal, so the hotspots is the Malacca Strait, North Borneo, Java and Sulawesi seas, which they have around 12 species. And of course, it's definitely widespread, but in the other regions, usually it varies between 1 and 3 species. Octopus. So widespread. So again, the central Ecoregions current, we can find 24 species. East China with 18, Philippines with 18, and Central and South Great Barrier Reef with 17. So these oranges here. The rest usually varies between 1 and 3 species. Of course, the Arctic and the oceanic islands are the places where there is less diversity of octopus. So, joining everything together, not surprisingly, we have this area of coastal set. Again, this is coastal diversity. So, Central Ecoregions current with 64 species, East China Sea with 59, Philippines with 48 species. The poles and the most oceanic islands range between 1 and 10 species. Alright, so this is the overall that we got from this database. plotting in a different way. So in terms of cuttlefish, here I'm combining the sepia and cephalopods all together, the cuttlefish, and they are more diverse in the Indian Ocean, followed by the Pacific. The squids, more or less the same, Indian and Pacific. The octopus, definitely more on the Pacific. And of course, on the overall, we have more octopus diversity in the Pacific, followed by the Indian, then the Atlantic. Okay? So here I'm going to show you a different approach. So we gathered the database in 5 degrees latitude bands. What to show you where the zeniths. And globally, you can definitely see that this is not unimodal. At least we can consider this bimodal. The Atlantic is different. So here is just to show you that the overall is one thing, but when we plot this with the other, according to the different oceans, it varies a lot. So definitely there is a lot of variation. You can see this little bit different for the squids. Definitely the squids really seem unimodal because they have a zenith here around 10 degrees north, and then, but it's just unimodal. More or less the same thing in Atlantic. So, but the take-home message is that on the overall, it's completely different from the cuttlefish. Octopus, the same thing, not unimodal, but definitely a bimodal. You see what is a bit strange. So now the overall, again, the pattern. And of course it varies a lot, like I said, among oceans. So one thing that we can say is, in terms of the zenith of the diversity, is it tropical? Yes, but probably just for the squids, not for the rest, right? So this is just a summary table of that 3 trends in ecology paper, where they just plot all the database available, and so you can find definitive fishes, corals, and they say unimodal, bimodal, symmetric. So I try to do the same thing here. So definitely, at the global scale, cuttlefish are not symmetric. They have variations among oceans, and they are bimodal and asymmetric. So not the same diversity among the north and south hemisphere. Squids, they have a peak on the north hemisphere, but unimodal. Octopus, like the cuttlefish, and the overall is definitely bimodal. What are we going to do? What are we doing right now? And I'm going to show you the stats. So we are plotting all these databases with different goals. So we want to try and test the species energy theory. So we are using the sea surface temperature and water temperature as a proxy. And what we want to test if the climate and organism physiology is dictating these patterns. The other theory is the productivity theory, and here we are going to use chlorophyll A. And because these theory argues that the rate of photosynthesis or active radiation governs the diversity of primary producers, and then all the other trophic levels in food chain. We are also going to try to test this theory that says that bigger areas promote higher speciation rates and lower extinction rates. So for this, we are going to use the continental shelf area to test this hypothesis. We also have these other general ecology theories like Cephalopod rule that say that latitude diversity gradients are associated with the reduction in the size distribution ranges of species towards the equator, and therefore it results in a progressively larger number of species along this trend. Last, among many others, we have the mid-domain effect that say that there is an increased tendency of species range to overlap towards the midpoint. So I'm not going to show you all this because it's just ongoing, but so keep in mind that we are doing all this to see if any of these theories applies to our database. But I want to keep Vasco with me, and we want to go even further. So on Japan, on Okadate, we spoke about the possibility then to expand to the epipelagic realm, but then following Spalding ecoregions for the open ocean. So after all this is done, we are definitely going on this direction, and then going to the mesopelagic diversity. There is a very cool paper that was published in Current Biology. It was published last year, and they split the open ocean, the mesopelagic realms, according to the position of the deep scattering layer. And so this is a gradient of mesopelagic biomass according to the position of the DSL. So based on these regions, we are definitely going to try to plot the cephalopod diversity in this realm. So this is what we are doing. Thanks a lot.